I would like to present cognitive solution on diabetes diagnosis based on Watson AI service on cloud. This is presented to the JK Hospital stakeholders. Outline, um, first of all, introduce the use case and the business requirements, and then the project management methodology for manage the life cycle. And this followed by the architecture overview, architecture decisions, and the user experience. Then project walkthrough. Walk through the Jupyter Notebook in Watson Studio. Finally, the future iteration plans. So first of all, the use case and business requirements. Use case is very straightforward based on the historic diabetes diagnosis data to create a diabetes prediction model which provides a prediction for patients who are likely develop diabetes with 70% or higher accuracy. This is iteration 1's goal, is 70%. In the future iterations, we may get higher. So 3 different steps is a build the model on Watson Studio and including the validate and the select the model. Step 2 is deploy the model to the Watson machine learning. And step 3 is apply the model, which is, in our case, is develop our chatbot application calling the API exposed from the Watson machine learning. This is a project management methodology I adopt. It's kind of the agile combined with the lean startup and design thinking. As you can see, there are 3 steps, 3 parts. The first part is the design thinking and inception, which is kind of design the many architecture decisions and inception, the data set preparation, and what kind of the model selection, all these kind of decisions made by the inception. And then it's quickly the lean startup, which is another 2 weeks. So in today's presentation, I focused on the first phase, which is inception and the lean startup, and the future iterations is going to be started from the number 3, and keep polish the model and enhance the application and models. Okay, so this is the end-to-end pipeline and architecture. There are 3 major components from this diagram. The top one is the very big one, is build the model from the in the Watson Studio Jupyter Notebook specifically, and the step includes the load of the data from the cloud object storage, which is CSV file, and doing the ETL and the EDA, and then and split to the label and the features. Label is yes, diabetes or not, and the features is including the different features collected from the patient, including, for example, BMI data, age, and glucose, insulin, and so on. And then training the different models. In this case, we're training 6 or 7 different supervised learning models and 1 non-supervised learning, which is clustering. And then we select 1 model, move forward, and publish to the machine learning. And after publish, we deploy it also, and the API is accessible externally through a URL and the bear token. Then the third component is developer application to access it. I quickly introduce the user experience. User experience is pretty straightforward. It's a chatbot. In this case, it's a Slack bot, and taking the features, 8 different features from the patient, and then we can return the diabetes or non-diabetes probabilities. So here I just have a very quick demo of the chatbot. So I ask check diabetes, and then the system will respond with the several different answers, the questions. So I just put in the different. Okay, after I input 8 features and it's come up with a summary and with the results. So which means in this case you get 84% with the non-diabetes, and you maybe have diabetes about 16%. So in all, this bunch of data from the diabetes perspective, probably you do not have diabetes for this patient. Okay, after the user experience demo, and then we go through the code. Okay, and so now we are open to the Jupyter Notebook and start from the beginning. And this is a summary of what the Jupyter Notebook covers. 3 different parts. First one is the supervised learning with the sklearn and the pandas library, and evaluate 6 different models, and we will pick one preferable one and move forward. In this case, we pick the random forest for the first iteration, and in the future iterations, probably we will keep adjusting and finalize and which model will be the best to move to apply. And part 2, we are also applied the neural network dense model feed forward neural network, and do the similar analyze for the kind of clustering. And part 3 is extend the pipeline to publish and deployment, and then have a very, very quick sample to do the evaluation. So the first part is the supervised learning, and the first of all is ETL, and to load the data and then do some EDA, basic analyze. And this is the data looks like. Data looks like it's in the pretty good shape already, and except something need to fine tuning up, including some zero values and also some columns I need to verify if they have the correlation to each other, and also check if there are non-value rows. So basically, when I do some transformation and here, and what I do is I replace the zero values to the mean value of the column. So this is called input, and then check the correlation. And so there are no correlation except the diagonal fields. And then I do some basic exploratory data analyze, and I understand that 65% is the data with non-diabetes, and 35% is with the diabetes. And for each field, I do some distribution analysis. For example, for the glucose overall, distribution, we can see 100 to 130 have the most of the people. And but for the diabetes people, and then we can get that's pretty the profile get higher, like 140, 160, and 180. So in this case, which means the diabetes people tend to have the higher glucose in the blood, so which is also aligned to the common sense. And also I create the pairs plot observation diagram, and including all the features, and looks like there are no alignment, like no correlation with the different columns. And then moving quickly forward, and I did the feature analyze, and we started to apply the model. And before I apply the model, I did split them to the training set and then the testing set, validation set. So 25% is validation, and 75% are training set. And if you can see, the profile is pretty good. 65% is non-diabetes and 34% is diabetes. This is in total. And then training set have a similar thing. And then also the testing set is slightly different, but mostly aligned very well. Then I apply apply to the 7 different models, including naive Bayes, logistic regression, and decision tree, LDA, and SVM, and the random forest. And they get pretty aligned. Mostly is 70%. Some of them they're like 65% or 68% accuracy. So move forward, I just use the random forest as an example to move forward. Move forward to deploy it to the machine learning. And also, I did some similar calculations on the MAE, analyze and draw the pictures also. And move forward quickly to the non-supervised learning. Again, non-supervised learning is just very quickly. I applied the feed-forward neural network dense model and with the 100 IP codes. And as you can see, the accuracy is fine. It's about 79%. But when I draw the diagram, is the accuracy and loss versus the IP codes. So this is have some problem, and looks like first of all it have some overfitting problem. The line is not smooth, and also with the increment of the IP codes, I didn't see the accuracy is only very slightly increased. So this is could something maybe future enhancement in the next iterations. Part 3 is okay. We finished pick the model, analyzed the model, and compare, and then we extended to the deployment. For the deployment part is pretty standard. We just using the same code to do the deployment to the machine learning. So in here, I use the Spark pipeline and then random forest, pick the random forest, and then move forward. And after deploy, there are several things important. One is model ID, and after model ID, we get the deployment ID. So we get the model published and a deployment, which is active code is deployed. And also, finally, we get two things. One is token, security token, and then the URL. The four things need to be get. So, and in the end, I just doing a quick test for the web service call, and then get the results. So if we go to the Watson Studio, we do have a very nice dashboard created for the model. So this is a model. You can see the model itself, and also this is a deployment, and also we can get all the different kinds. For the deployment itself, we can even do the simple testing of the deployment on the Watson Studio, which is access to the Watson machine learning service. And then here is to do the testing. So finally, after walk through the Watson Studio and the Watson machine learning, and then we come to the client side, right? We are the application side, which is the user experience. I already demonstrated the chatbot, and then chatbot is written by the Node-RED. It's just a very rapid development tool based on the Node.js, and then created the Watson Assistant, the dialogue design. So this is pretty much all for the achievement for the first iteration and inception phase. And for the future iterations, we will continue enhance the models and to enhance the models, get better accuracy, and finalize which model we will keep using. So far we are using the random forest. We will keep tuning the parameters and weights to see what kind of model is best and adopt here. And the second thing is the enhanced application. The application currently is the chatbot. It's a Slack bot, and in the future we can, based on the stakeholders' feedback, we can doing even the voice, like a real natural language conversation. All those kind of nice features put into the picture. And finally, after we get a very good diabetes cognitive solution, and we can extend the solution for the other disease diagnosis, such as cancer or heart failure diagnosis, and so on. So this concludes my presentation on the project of the diabetes diagnosis solutions based on the AI, IBM's Watson solutions.